is easier with a free subscription to the Discovery Network's Educator Guide. Providing program schedules and descriptions, this easy-to-use guide will help you tape copyright-cleared programs for classroom use. And turn to the Internet for supporter resources at Discovery Channel School Online. Make Discovery Networks work for you. Call 1-800-321-1832 or find us on the World Wide Web at school.discovery.com. Coming up now, study and discussion questions for the brain, our universe within, perception. Where in the brain is visual information filtered and coded? Why does every person have a unique neural map? Discuss some of the influences, such as experiences or emotions, that can affect a person's perception. How might this explain the existence of certain prejudices? Assignment Discovery now presents The Brain, Our Universe Within, Perception.
How in the world do we make sense of the world? We do it with something called perception. I've lived in North America all my life. To my friends and colleagues, I'm considered Japanese. But when I'm here in Japan, people know instantly I'm a foreigner before I even utter a word. Our culture has a big part in creating our perceptions. But it all starts up here. The brain actually physically constructs and colors a world for us. The brain takes the chaos out here and orders it in a way it decides will be most useful for us, allowing us to see, smell, and hear certain things. But how does the brain do that? We're about to find out. I'm David Suzuki, and I'm going to show you how the world up here shapes the way we perceive the world out there, and what it means to see and not see.
The world of art bears a fascinating truth about brain study. Each of us sees the world differently. Vision, or visual perception in the brain, is a unique experience. You and I may look at the same thing, but thanks to our brains, we see it differently. We begin this journey into the brain where we'll see how we see. Our eyes may be the front doors to vision, but strangely enough, they aren't where sight happens. It starts when incoming light is converted to electricity by these strange devices called rods and cones. Kiki, whom your eyes are gathering now, will help us with the rest of the trip. First, incoming light information is flipped upside down. Next, the information breaks up into fragments. Then, at the crossroads of the visual fields, it splits. Sorry, Kiki. The fragmented pieces then make their way to the primary visual cortex, found at the back of the brain. This layered region filters and codes the information. Now Kiki's trip gets even more complicated. All that coded information is parceled out to as many as 32 locations for finer processing. The cerebral cortex, The brain's quarter-inch thick thinking cap consists of tightly packed columns of nerve cells. It's the number of columns and their complex web of neurons that set us apart from other animals, what makes us human, in fact. Here, we finally see the world. Inside each column, neurons form networks of fierce activity. Information continually bombards the brain. To manage it, the cortex uses the division of labor principle. Here, neurons begin sorting the still jumbled scene. We know Kiki is in there somewhere. Every column has a complete set of neurons, each designed to seek out a specific angle from 0 to 180 degrees that might be found in the various shapes within the scene. It's a bit like finding the edges of a jigsaw puzzle first. As the process continues, thousands of lightning-fast tasks rage beneath the brain's surface. It's a race to make the round edges sharp, to find in the incomprehensible jumble something or someone we recognize. Eventually, the outlines of a face appear. All of these visual bits and pieces are processed and coded by assigned neurons. While one set of neurons is busy reading the contour of a cheekbone, another will read the shape of the eyes or the slant of the nose. It's an incredibly evolved bit of natural computing, and at the end of this split-second journey, when everything is reassembled, a familiar image appears. So many combinations. Experts speculate that the brain builds on what it learns while processing simple patterns, enabling it to perceive increasingly complex shapes or other forms of information. This woman suffered a stroke 14 years ago. Now her view of the world is dramatically skewed. She cannot detect how full the glass gets. She sees the water, but she doesn't see the water rising. She can no longer detect motion. The stroke interrupted the neural pathways that process motion, the where of the visual scene. Hers is the only reported case of its kind. The world her brain sees for her is terribly disjointed. synapse to cross, the pathway is almost an open road to the brain. Though they are spread throughout the cortex, olfactory neurons have particular circuits wired to the limbic system. That's where our emotions sit. And to the endocrine system, where hormones are produced. Because of these special links, we can think of smell as the most excitable of our senses. With the sense of smell, we sniff out foods we like and dislike. Smells produce cravings. They arouse, stimulate, and frighten. They also send warnings about things that are otherwise undetectable, like leaking gas or spoiled food. Thanks to the strong emotional link associated with smells, we don't easily forget negative experiences, like getting sick from certain foods. The smell alone can trigger symptoms of nausea, lest we forget and give the food another try. The last sense through which the brain receives information from the outside world is taste. The receptors on the tongue are geared for picking up just 4 basic qualities of taste: salty, sour, bitter, and sweet. All the more subtle tastes we experience are largely a function of smell. Our bodies need certain foods, yet our eating habits are mostly learned, a result of tradition and culture. These food preferences are built up and stored in the brain's memory banks, spread in neural networks throughout the cortex. So even though we might not be aware of it, our brains use their stores of memory to determine what foods we select to eat. There's still a great unsolved mystery locked deep within the brain. We know that information bits sweep through the cortex in such a way that a clear perception emerges. But no one has proved how or where exactly this information gets assembled. Dr. Antonio Damasio is a leading neurologist at the University of Iowa Hospital. While some search for a final assembly point for perception impulses, he's not so sure there is such a place.
You probably don't need to have a place where it all comes together. In fact, there is I don't think there's any evidence anatomically that an image of sound, like the image of my voice now in your brain, or the visual image that you're now having of the scene, that they ever will coalesce together in the same structure. I don't think there's any evidence for that. I think that what you have evidence for is that they can be temporally synchronized. And there is evidence that there are structures that have signals that hail from those respective images. And therefore there's a linkage, but the linkage is not made at the level of the image itself. So it's not my image of your face together with my image of your voice in the same cortex. I think that those remain separate, but they can be brought online at the same time.
Currents of data feed forward throughout the brain and then loop back, from sensory areas to memory centers and back again. Based on new imaging techniques like functional MRI and PET scan, many researchers now believe that perhaps these parallel networks bind together in synchrony, a kind of harmonic convergence to produce what we call perception.
So I have all this activity going on that is representing you in perception right now. And what my brain is actually storing is not your picture, but rather the mechanisms that are being utilized to create the perception of you. And tomorrow, when people ask me about you, I'm going to go into those mechanisms and I'm going to try to make them do the same thing that they're doing today. And then they're going to generate an image that is not going to be quite the same as seeing you right now, but it's going to have a lot in common with what it is being done today. So what I'm going to have is an attempt at replicating the patterns of activity of today. And during that period, I create an image and I bring on lots of other images that pertain to you.
Sensory data constantly stream into the brain. Our brain attaches associations and memories to allow us to make sense of what we see, hear, and touch before us. We perceive the world as a constant, unified place, and that's because the brain acts as a filter. From infancy, we build maps of experience. These maps for seeing, tasting, and touching, for memory and emotion. These maps, when similar from person to person, are what bring individuals together into a society or culture. Our perceptions are often shared, but our brains also make them uniquely our own.
Amazing to think that the physical universe around us is deconstructed, then reconstructed by this inner universe called the brain, and that these perceptions become, in fact, our reality. Long ago, my brain told me to appreciate a hot dog with mustard, but to avoid the relish. Long ago, it had no experience of the seafood delicacies here in Japan. The neural maps in here come to reflect our culture. I've learned to enjoy relish and Japanese seafood. If my brain lacks or reflects certain values, I can add or change some of them. And even if my neural networks don't look like your neural networks, does it really make me that different from you? Is my wiring somehow better or worse than yours? For the Discovery Channel, I'm David Suzuki.
日本語で話してください。
Coming up now, answers to the questions for the brain, our universe within, perception. Visual information is processed in the visual cortex, located on the back surface of the brain. No two neural maps are exactly alike because our individual experiences influence their development. Try this activity with your class. Divide the class into two groups and have each group invent and conduct an experiment that demonstrates how we perceive sound direction. Then describe the experiment and the results to the class. To learn more, members of the American Association of School Librarians and Assignment Discovery suggest Your Brain, How You Got It and How It Works by Tabitha M. Powledge. Ask your librarian to help you explore the many resources your library has to offer.